We're glad to have E.Y. Kalman with us, who will be presenting this series. He is a Microsoft Certified Trainer and a Microsoft MVP for business applications. He is currently based in the UK. If you happen to face any audio or video issues during the webcast or have any technical questions, please post them in the Q&A panel and our team is here to help you. So let me now hand it over to our presenter. Kalman, the floor is yours now.
Hello there, and welcome to the virtual training series for the AI 900, Microsoft Azure AI Fundamentals. My name is E.Y. Kalman. I am a Microsoft Certified Trainer and a Microsoft MVP for business applications. The overview of the entire course is as follows. It's really split up into 3 modules. Day 1 is around getting started with AI and exploring computer vision in Azure. Day 2 is around NLP, natural language processing, and conversational AI in Azure. And Day 3 is around ML, machine learning, and how Azure uses it. And as you can see on your screen, these are the sort of topics that we're going to be going through. So for Module 1, which is this course, we're going to be discussing and seeing the features of common AI workloads, what they are, how they support us, some scenarios around how they should be used, and just how we can look at deploying them for ourselves and our customers. We're also going to touch on guiding principles for responsible AI, because AI can obviously be used in a variety of scenarios, some good and not so good. So we obviously want it to be used in the right way, and there are guiding principles which Microsoft has around responsible AI, and which we suggest that every company and customer that will be using Azure AI along with other AI services should be putting in place in order to protect themselves and their customers and really use the technology in the right way. We're going to be focusing on computer vision in this module, and computer vision is really around seeing. After all, that's what vision is, although computers don't see, but they would process images. So there are various different types of image processing that the computer vision service in Azure does, using AI around it. Those could be ranging from object detection, so knowing if there's an object in an image and where it is, to automatically flagging that an image does contain something or not. For instance, a building or a hot dog or a badger. And really diving into seeing what are the tools and services that Azure has around it, because there are a number of pre-built models that are available to use already out of the box. Then again, there's also the ability to go ahead and custom build your own models around it, and obviously it will depend on the exact scenario that you or your customers are working with, but sometimes it's really helpful and useful to be able to use one of the pre-built models rather than going through and training your own, at least in the first instance. And what we will be doing later on in this module is I will also be going through several demos of the technology, just showing how it can be used, again just through the front end. I'm not going to go through the whole back end setup of it, but just how it can be used and some examples using, some test data. So let's go ahead and start the module, which is all around getting started with artificial intelligence and exploring the computer vision in Azure. So the first thing that we're going to do is we're going to go ahead and we're going to take a look at features of common AI workloads, because there are common tasks carried out by AI, such as Azure AI and other things, which relate to everyday life and the everyday business, and really what you're seeing for you and your customers on a daily basis. There's obviously some very custom stuff, but if we can take a look first, we're going to go into this. So there are workloads around prediction and forecasting, and the machine learning's ML stands for machine learning. Deep learning allows for things like time series of data. And if we take a look, I'm not going to read through this on the screen, but if we take a look at this, what this means is we can take historic data and we can look to forecast and predict trends on it. And the machine learning that's in the system allows us to use native time series and deep learning models as part of the recommendation system around it. Now, some of the industries that will be looking at this will be things like travel. If we look at the airline industry as a general thing, they'd like to be able to predict times of the year when they would have more passengers, and therefore they need to route larger aeroplanes on specific flight paths in order to accommodate that. Or if we take a look at hotels, they're also going to want to look at data and predict as to when their peak times will be, and then they can do their pricing accordingly and ensure that they have a variety of resource available. Those are two of the items that will work on massive time series and can give it a massive amount of data to be used for it. Now, there are three different models that are used for this, and they are Profit, Auto Arima, and Forecast TCN. So Profit, for instance, works with time series that have strong seasonal effects and at least several seasons of historical data. So it doesn't matter if you've got some missing data or you have some outliers on the trend or dramatic changes in the time series. It's still actually really good around it. The next type of model, Auto Arima, works best when the data is stationary. It has something called a univariate series, and univariate series means that there's only one variable that can be observed at every point in time. If there are two or more variables able to be observed at each point in time, that's called a multivariate time series. But Auto Arima works very well when, for instance, predicting sales amounts. If we can turn around in a company and say we know the total cost of sales, or the total amount of sales on a specific day, a specific week, or a specific month, we can give it a time series. That data is stationary, it's only one item at a specific point in time. Of course, we could look at different models, different items that a company is selling, but it would only be one figure, for each model overall. And therefore it can take that and it can predict over time, for instance, what the projected amount of sales would be for a specific day in the future, or a specific month, or even a specific year. Now, again, the amount of data that we feed it is vitally important in this point, because obviously the more data that there is, the more accurate, hopefully, the model will be able to train to be. And really building on these two is the Forecast TCN model, and Microsoft has built essentially a neural network for tackling the most demanding forecasting tasks. It takes the models that we've got here and it allows us to have larger data, deeper learning models to improve the scores of the resulting models from it. It's capable of taking complex trends in the data and scales to the largest of available data sets, which Profit and Auto Arima don't necessarily do. It also captures non-linear data, as well as it looks at relationships between time series. So again, it really takes the model ability to the next level in terms of what it delivers from it. Now, obviously prediction and forecasting workloads are very important, but they're not the only thing that it's important to do, because not only do we want to be able to detect what it could be in the future, we also want to detect anomalies. And that's where the anomaly detection workload comes in. Now, anomalies are actually quite important in data because we're actually looking for them, but because they are by definition rare, they are an anomaly to the main events that are happening, it can be really difficult to collect them. So there are some algorithms that have been put in place in order to specifically identify anomalies in data sets. And there are quite a few industries that will be vital to identify anomalies, because an anomaly may not be what you or I consider to be strange, but it could be something different. If we think of financial institutions, so financial institutions, in terms of issuing things like credit cards and debit cards, previously checks of course, will want to look for fraudulent transactions. So what they do is they will take the spending history of a customer and they build this up over time to present a pattern of which they can see where the sort of average trend is and where it isn't. And that's not just based on the amount, that can be based on the location, whether it's in person or whether it's on the internet. They will take the actual location as well from it, the device potentially that it's there with, the type of service even. So has this customer purchased this type of service before for this type of provider? Because of course each type of provider, food and beverage or hotel or travel, has a different code, a merchant code in the credit card system. So we'll take that into account as well. You can even take into account the time of day and the day of the week in which things are going, and it builds up a quite a decent accurate model over time, which is very important, because then when something happens that's out of the norm, that's the anomaly, it will then flag it as being something to query. It could potentially be fraudulent, and this is how financial institutions go around these sort of things. I know personally, I've had a couple of times over the last few years, my bank actually call me when I've put a transaction through and they say it doesn't match our predicted model for you. Can you confirm if this transaction was valid or not? And people will nowadays get push messages with an SMS on their phone or an email to say, your card has been used in such and such a place. Please confirm that it is indeed a valid transaction. So this is one way in which anomaly detection can be used. Several other ways, for instance, are around IT systems. Networks being secure or unsecure, is there different MAC addresses? Are coming from if we think of a website, is somebody accessing from an unknown location that they haven't accessed before? So things like that can allow us to have better network security around it. If we think of the healthcare system as well, patients with results, we're trying to look for those patients who are outside of the norm for it, so an abnormal cluster, so we can get the results in of patients who have been on treatment for various medical conditions. We can put in the drugs that they have taken, the medication that they have received, the other treatments that they have received, and machine learning builds up a model of that. So immediately, even quite early on, it can be possible to identify somebody who isn't responding in the right way, because if you have, say, 98-99% of people who respond in a specific way, and you have that 1% or even less than 1% of patients who are responding in a different way and need additional care, or they could potentially, for instance, be allergic to a medication, but we don't know it at that point, we can only see as it goes along, we can catch those things earlier and therefore provide better services to them and catch medical situations. So really the algorithms, as it says, included in this category, have been designed, to look at those outliers, to look at the issues that come when looking at a data set in which you may only have a minuscule amount of the data set, which actually are the anomaly data records, but to be able to flag those up and use those to train the model on and to continue going through it. Again, the larger the data set that we can provide, hopefully the more accurate things will be. Now, the anomaly detection is available as an API to be called. It said it's built with Azure Machine Learning, and it can detect several different types of anomalous patterns in time series data. So for example, it can look at positive and negative trends. Example, monitoring memory usage in computing. You might be interested in, there's an upward trend, more memory is being consumed. It could be indicative of a memory leak, or that there's been a problem with something and therefore the trend goes down, and you can see it's because it stopped, there's been an exception or something like that. It can also look at changes in the dynamic range of values. Again, if we look at exceptions in terms of programming, any changes in the dynamic range of values that are there could indicate instability in the health of the service, and therefore need to be taken a look at to see what has caused the problem. And on the top of just that, not just the change in the dynamic range of values, but also can look at spikes and dips. So for instance, if we take a look, if we think of online shopping, the online retail experience, we could see logins for it. We could see the data around successful versus unsuccessful logins, or for instance a number of checkouts around that. If you have spikes or dips, that could indicate abnormal behavior. If you would normally see, say, 1,000 logins a minute and suddenly it's dropped to almost zero, that's a massive dip. Is your website actually up and running? Is the login page up and running? Or spikes? Are you getting hammered more and more because of it, and therefore you realize that you could be under a denial of service attack, for instance. So this can be really helpful for a massive number of verticals, obviously each customer applying it in their own way, but to start taking a look at their data and work out how can they best support various scenarios, and of course be alerted when there is something that is out of the norm, which is really what an anomaly actually is. Natural language processing, or knowledge mining workloads, is another functionality available. In Module 2 we're going to come on more into the natural language processing, or NLP, subject, but it's got a massive number of items in it. It has things like entity recognition, language detection, sentiment detection, and a variety of other things around that. And this is really around how AI enrichment is an extension of what we call indexers. And what indexers are, it's really sort of like a crawler. It extracts searchable data and metadata from data sources and populates an index in an Azure database based on, say, field-to-field mappings between the index and the data source. Sometimes referred to as a pull model because it pulls in data without you having to write any code that writes data or that adds data to the index. Now, it's possible to use an index as a sole means for data ingestion, or use a combination of techniques that includes the use of an indexer for loading just some of the fields in the index, and these can be run on demand or on a recurring data refresh schedule that can run as often as every 5 minutes. Now, why would we use these? Well, it's used to extract text from images, blobs, and other unstructured data sources. So if we think of documents that are sent in, we can look at things like invoices, or we could think of things like a social media feed. It's possible that's all unstructured data, and it's possible to take that and put that into a structured data reference. And with this, it allows the unstructured text to be mapped as searchable and filterable in an index. So we can take that and we can do things on it. We could, for instance, if we were monitoring a social media feed, we could see how people are thinking of a specific customer. It uses sentiment analysis to see what the sentiment is. Is it positive sentiment? Is it neutral sentiment? Is it negative sentiment? I know of several airlines that use this on their social media feeds to see how customers are interacting with them on an ongoing basis, and to identify any anomalies or items where, for instance, sentiment analysis is negative, to go ahead and try as quickly as possible to resolve the situation that's occurred. Now, Azure Cognitive Search has built-in skills around this, and there are pre-built training models to be used in part of the Cognitive Services APIs. So you don't even need to go ahead and start building your own ones from the get-go, from the immediate start. You can use some of these pre-trained models that are available to use right out of the box. And we'll see a couple of these slightly later on when we start going through the demos. Now, one reason why we would look to use these for ourselves and our customers is if we have a large amount of what we refer to as the unstructured data, as I referred to a minute back. If we can apply AI skills to it through the built-in cognitive functions, we can unlock this content, thereby increasing the value and utility in things like our searches that we're doing and data science applications. This can then be used further on down the line when we look at how we take that data and what we would do to use it to really better our services and the items that we provide to customers. And how will we go about doing it? Well, again, it's available through the APIs. It's not just APIs, there are SDKs there and various services around which are there for developers to be able to connect into and to build it. And really the reason for having the entire Azure Cognitive Services is that we can create applications, apps, whether they're running on desktop or laptop or mobile phones or tablets, but they can take data from the variety of sources that it's there. So with vision, they can go ahead and they can see things, they can process visual information. With the ability of the speech API, it's possible to add speech-enabled features to applications. So we could create a translator app to translate between two languages, taking speech as an input, identifying it, and then turning it around and giving us an output in a different language. Things like the language API. So understanding what a person wants in natural language. If we think of the ability to service customers in their own way using natural language, the machines can then understand what they're wanting with, say, using local phrases and things like that. That's absolutely amazing. And again, to provide translation, a customer could be communicating in one language and the machine automatically provides a translation of it in a different language to a support agent. They don't need to be speaking each other's languages at all. Underneath it, cognitive services allow that immediate real-time translation, which can be very helpful in today's world, whereby companies are on a multinational basis or global basis, and you could need a customer to connect to a very unique support unit for something that they have, and the only people available don't speak the same language as the customer does. With cognitive services, we can allow this real-time translation, which is very, very accurate, to be able to service the customer in the best possible way. And finally, there's also the sort of decision one, as in it takes the decision for it. So an example of decision could be what financial institutions are doing nowadays, which is if we think about the ability for people to apply for mortgages and loans, we provide all the information, and they will have generally a trained model to identify immediately whether a person is applicable for it and eligible for it and to grant it, or whether they're not. Now, as we're going to talk in a couple of minutes around the human need, even with AI in place, and obviously around using AI in the right way, but it could be, for instance, an easy way to allow a majority of people who want to apply, say, for a mortgage or a loan, to be able to get a decision almost instantly and not need a human involved, and which would take up more time. And then in cases where it returned the result that said no, they're not eligible for it, that can then be passed over to a second level where a human being, then goes and reviews it to see if they actually aren't, or if they could be eligible as well. The human factor really is important around this, of course. Now, if we go back for a moment to when we were talking about anomaly detections, and there are two modules that are available in the Machine Learning Studio to create an anomaly detection model. They are the one-class support vector machine module and the PCA-based anomaly detection module. And to explain a bit more around it, the one-class support vector machine, or SVM, as it's usually referred to, has an algorithm to take data and identify it as belonging to one or two classes. And it's really used where you have a lot of normal style data and not many types of the anomaly that you're actually trying to detect. For example, fraudulent transactions. You might not have many examples of fraud that you could use to train, but you would obviously have many examples of good transaction. So an SVM model is based on dividing the data set that it's provided for training, there's points within it, into separate categories by as wide a gap as possible, whilst penalizing training samples that fall on the wrong side of the gap. It then makes predictions by assigning points to one side of the gap or the other. So therefore, in a one-class SVM, it's trained on data that only has one class, which is the normal class, and from that it can infer the properties of normal cases, normal situations, and from these properties it can predict which examples are unlike those of the normal examples. And this is therefore useful for anomaly detection because of the scarcity of examples within the dataset of what defines an anomaly, i.e. that there are very few examples of them around. So therefore it would take the data coming in and it would then say, does it fit within the norm? If it doesn't fit within the norm, at that point it's classed as an anomaly. On the other hand, PCA-based anomaly detection stands for Principal Component Analysis, and it's an established technique in machine learning. It's frequently used in exploratory data analysis because it reveals the inner structure of the data and explains the variances in that data. It works by analyzing the data that contains multiple variables, and it looks for correlations amongst the variables and determines the combination of values that best captures difference in outcomes. It can then take these combined features and the values from them, and they are used to create a more compact feature space called the principal components. So if we take anomaly detection, each new input is analyzed, and the anomaly detection algorithm computes its projection on the various vectors, together with a normalized reconstruction error. And it takes this as the anomaly score. The higher the error, the more anomalous the instance is of when it's occurred. This therefore can take those multiple variables. For instance, when we look at financial institutions and use of credit cards, it could take the amount, the vendor, the date, the time, the day of the week, the location, all of that, the type of method, whether it was in person, it was over the phone or over the internet, and it puts all those variables together, and it can therefore build a very accurate model to try and work out what would be an anomaly and therefore quite potentially fraudulent, or what is not an anomaly and therefore would pass. So we take all that data in the data set and we label it and we put it into the system, and we then train the model to be doing it. And once we've done it, then we can then use that trained model, which we can iterate the training on, but we can use that trained model within our application. We can feed data into it on an ongoing basis and see the results that come out of it. So let's continue through, and we'll take a look at the computer vision. And this is really one of the core areas of the AI. And the aim, as said previously, is sort of those 5 different pillars that it's aiming to do. It's one of them. It's very key to it, because systems will take data in image format, whether that's a live video stream that's going into it, or pictures that are given into it, or scanned documents as an image file or as a PDF. It can take all of that information and can work on it, and there are so many different applications that can be used from it. As we can see here on the screen, it can take an image and it can suggest an appropriate caption, what the type of image is. It could suggest relevant tags using to index. If we take a look at an image, they're wanting to put an index for searching, we can have different tags. It could be called a house, it could be called a building, it could be called a different item for it. We can also categorize images and identify it within there. If we think of supermarkets, we could take a picture of a supermarket shelf, and then it could identify the items, the objects that are in that image, how many cans, and potentially even what cans belong to which manufacturer, or the size of the cans. It's possible to detect faces and people in an image, and not just that it's a person, but there are pre-built models available that are trained around showing celebrities. So we could show, is there celebrity in the image or not? And it can also use optical character recognition, OCR, to read the text that's in an image. If we think about things like form processing, which we're going to show a demo of shortly, and it could take invoices, and it could automatically take data from that invoice and then take it away and input it in a different system. So instead of somebody needing to manually do it, we're able to use AI capabilities to do that. And really about vision, under it all, an image is just an array of pixel values to the AI application. So these numeric values can be used as features to train the machine learning models that make predictions about the image and the context. So although there are pre-built models available, it's possible for us to go ahead and create our own models based on the data we're feeding and what we're wanting to identify or analyze and return results of from that data. And with this, developers go ahead and can build custom applications to use these capabilities in it and surface it in. So let's go ahead and take a look at several of these items available. And the first one is really, describing an image. So the Computer Vision Service, an API in Azure Cognitive Services, offers pre-built algorithms that can process images that are uploaded by users. And what this service does is it then returns specific information about the contents of the image supplied. So this could be possible again in an application to work out if something is the image or not, and it can then allow images to be uploaded by users within the application or within a website, for instance, and it can then say, has it returned it or not? And based on that, it generates a human-readable phrase or sentence to describe what's been detected in the image. Now these will be returned in the order of confidence, and this is obviously based on how the model sees it. So for instance, for the picture that we have here, it will show in order a black and white photo of a city. That's the most confident statement about it. And then slightly less confident is a black and white photo of a large city. And then even less confident than that is a large white building within a city. And here we're talking about the Empire State Building in New York. Now, depending on the image contents, we could find multiple results or phrases returned, as we've seen here, and each return phrase will have that confidence score next to it based on how confident the algorithm is in the supplied description. So this can be returned back to the underlying application that's using the service, and it can then decide what to present to the user or how to proceed based on that. There's also the ability for visual features, because the image descriptions that are generated by computer vision are based on a set of thousands and thousands and thousands of recognizable objects. And these in turn are able to be used to suggest tags for the image. And these tags can be associated with the image as metadata that summarizes attributes of the image and can be particularly useful if you want to index the image along with a set of key terms that might be used to search for the images with specific attributes or contents. So, for example, for the Empire State Building, the tags returned include skyscraper, tower, and building. So if we think for something like we're wanting to give images available to users, they want to search for a tag that they want to use an image in a document, and they put a tag in, it can then return it. This based on an index of data that we've already fed into the system. But it doesn't just return phrases and tags. It's also possible to detect exactly where the image is within the larger picture, within that item itself. And this is object detection. And it's quite similar to tagging in that the service provides the ability to identify common objects. But rather than just tagging or providing tags for the recognized objects only, it also returns what we refer to as a bounding box coordinate. And this is a square box, well, it could be obviously rectangular, it doesn't need to be absolutely square, but outlining the item in the image itself. And together with this comes a series of coordinates indicating the top, left, width and height of the object detected, which is used to identify the location of the object in the building. If we would provide an image containing a family in a park, for instance, it would be able to return the dog, assuming that there is a dog with the family, but it could return the dog with the family with its own bounding box coordinates. It would return each person in the family with their bounding box coordinates that is there. So that way we can know if an image contains multiple instances of a certain object and where in the image it's located. This could be particularly of interest, for instance, in the home security sector, commercial security sector, whereby they're using security systems that have cameras for perimeter security. If they have motion detection enabled, we don't want to be alerted every time the boundary is crossed, say by a squirrel or by a badger. We'd only want to be able to do this when a person actually crosses that boundary and triggers it, and then we could take the result that comes in to say it is a person and this is location, and we could then automatically feed that through to the camera system to be able to focus in on that area, in on that person. It's possible as well to detect things like brands. So thousands and thousands of commercially recognized logos from across the world, from a variety of brands, are able to do so. They can recognize, is this brand in the picture or not? It's there or it's not there. And there are a number of categories that are available in sort of a parent and child setup. So when it analyzes an image, they're compared to existing categories to determine the best way to provide that categorization. Obviously not everything will fit in with them in that model, but usually most things will, and then it can bring back the appropriate way to categorize it. Now, going one step further than just seeing the bounding box coordinates for something and whether it's there or not, it's possible to do even further things. It's able to identify faces, and again where it is, the approximate age and gender, and again give a location where within the image it is. And this feeds through into things like celebrities. It's got a celebrity database available, so it can turn around and say whether, for instance, Satya Nadella is within the image or not, and if he is within the image, show where within the image he is. Now, obviously this needs to be used in the right way for facial detection and facial recognition, and we're going to come on to responsible AI shortly, but this is what it's able to do around it. It's also able to do a similar sort of thing for landmarks. Again, pre-built models with thousands and thousands of landmarks from across the world. So it could pick up the Empire State Building in New York, it could pick up the Colosseum in Rome, or it could pick up the Sydney Opera House in Sydney in Australia. It's able to go and do that because it's got those pre-built models available, so it can tell you if it's in the picture, if it's in the image that's been uploaded, and if it is as well, it gives you that bounding box coordinates to know where within it is. There's also color scheme availability to detect the color scheme, so you can turn around and take a picture and say what is the dominant color scheme overall, or the foreground picture, or the background color, and it will return all those values in a message that can be then used as the application wishes to for it. Example of what could be helpful for this, for instance, could be analyzing satellite images of rocks for mineral exploration, for instance, or trying to identify things like rainforest, how much of the rainforest is still around and still in certain areas, whereby we're taking things like satellite images or images from very, very high up, and they can then turn around and see the percentages based on the colors for it. Even if it's a false color, it can still respond to it and give the abilities to be able to use that then in further data analysis and extraction. Now, I've mentioned once or twice already around responsible AI, and we have these guiding principles which Microsoft has put in place around this, because it's very important to use AI in the right way, because some of the capabilities we talked about could obviously be used in the wrong way. So there are various considerations to take into place. The first one is around fairness. And the reason for talking about fairness is because as we train AI models, we can either cause an AI system to either give the opportunity to a specific group of people, or withhold an opportunity, or other types of things like resources of information, from a specific group of people. It's also possible to harm the quality of service, so it could, by its very nature, not work as well for one group of people as it does for another. If we think about regional dialects, for instance, it may recognize one regional dialect much better than another regional dialect, and even then, if you have two people saying the same thing, it would recognize one much better than another and give proper services to the first group and not to the second group. If we think about in terms of opportunities, there, again, if we think of financial institutions, it could be potentially be slightly biased towards certain groups of people in allowing mortgages to go through, rather than other groups of people who may not have such a good history on a financial basis, and therefore mortgages would be more of a problem for it. Examples also of allocations in terms of job opportunities. People who are submitting from, say, certain backgrounds may have automatically a better chance, because of the general data set available to the model when it's trained, than people from other types of backgrounds. So it's important that in order to reduce any unfair behavior, we have to assess and mitigate these harms. And there's something called the Fairness Assessment and Migration Module, and this is called FairLearn, amazingly. It's an open source Python package that allows machine learning developers to assess systems fairness and to put in mitigation actions around it. And what this has is a series of algorithms which essentially are there to mitigate the unfairness factor for it. And it supports a set of constraints on prediction behavior called parity constraints or criteria. These require some aspects of prediction behavior to be comparable across the groups that have sensitive features, for instance, different races or different locations or different ethnic backgrounds. The mitigation algorithms in the FairLearn open source package use parity constraints to mitigate the observed fairness issues. Now, it's not possible to mitigate it entirely technically. It cannot eliminate the unfairness completely. So what FairLearn does is it provides suggested mitigation strategies to help reduce the unfairness in a machine learning model, but it's not absolute solutions to eliminate the unfairness absolutely. There could be other parity constraints or criteria that should be considered for each particular system, and developers must determine for themselves if there is sufficient mitigation in place to eliminate any unfairness in their intended use and deployment of machine learning models. So the way that this is carried out through FairLearn is it's called group fairness. So ask sort of what groups of individuals are at risk for experiencing harm. So those could be based on gender, or based on age, or based on financial background. And it takes those as sensitive attributes, and it therefore quantifies those through disparity metrics. And there are a variety of metrics which calculate it in the value of the selected performance metric across different subgroups. So for example, it could be disparity in accuracy rate, or disparity in error rate, or disparity in precision, disparity in recall. There are many others available, and it takes all those and it goes away and it assesses that, and it can then work out how fair or unfair the model actually is. And here we can see that the following types of parity constraints are available. We have demographic parity, equalize odds, and bounded group loss. And each one works in a specific type of machine learning task. So we have binary classification, a regression available, and things like demographic parity work with both, whereas equalize odds just works with the binary classification, and the bounded group loss works just with regression. But really all of these different parity constraints should be used and identified when we're using AI for machine learning and building up these models, just to try and really take that fairness factor across everything, rather than the model essentially becoming unfair to a specific group or groups of people. The next item around responsible AI are things like reliability and safety. Now, it's absolutely critical that AI systems obviously operate reliably, safely, and consistently under both normal circumstances and unexpected conditions. And it can be very hard to test unexpected conditions, but it's still important to be able to go ahead and do this. That's why absolute rigorous testing is vitally important when building systems out for this. It's not just during the initial system development, it needs to be on an absolute ongoing basis, because if not maintained properly, AI systems could become unreliable or inaccurate based on data there has. Maybe data trends have changed, but the AI system hasn't changed. It hasn't learned with new data set. It hasn't been retrained to do it. So it's important to keep this on a continual development to ensure that it's, as safe as possible, as reliable as possible, and it can keep getting better over time as well. Really, how systems behave and the variety of conditions they can handle reliably and safely largely reflects the range of situations and circumstances that developers anticipate during the design and testing. And that's why it's important to try and drop a list of as many items as possible, both expected and unexpected, to be able to test for as the systems are built and the models are implemented, trained, and put in place. Without this, we lose confidence in the AI solution, and then the company will have confidence lost in its products. Another thing that can cause confidence to be lost is not having privacy and not having security. Well, it's absolutely important that any situation in which we have AI models and AI solutions rolled out respect privacy and security. So if we think about things like GDPR within Europe over the last couple of years, and there are similar items in other locations around the world, if customers are providing data, the system needs to respect that and needs to have appropriate controls in place for securing it and keeping it properly stored in whichever place it's being stored, as well as obviously removing it on the limitation of the ability to capture the data for it. And we should be putting in place that consumers have adequate controls about how to choose that their data is being used, which is again vitally important and enshrined in legislation around the world. If we can't show that we are securing data properly and we are respecting people's privacy, then that creates an immediate blocker to customers using solutions that they're provided with that have AI underneath. It should be the same as the way that they are handling with human interactions within companies as within their handling systems that have AI in place. It's also important that we have inclusiveness in our solution. 1 in 10 people in the world have some sort of disability, whether it's easily identifiable or not. So intelligent solutions, things like real-time speech-to-text translation, visual recognition services, and predictive text functionality, absolutely important to a really large sector of people who have things like hearing or visual or other impairments. Therefore, it's important to have inclusive design practices. We need to look at how we can be more inclusive with what we're doing with the solutions, and the AI capabilities, the cognitive services Azure offers, really can enhance this to people who otherwise would be unable to use the technology. So not only are we providing solutions to customers to use everyday things and get better at what they're doing, we're providing the ability to people who would otherwise not be able to use the technology in any way. The ability to have speech read out from a system so that somebody can listen to it. The ability for us to identify something that somebody can't necessarily see. And therefore, by using the technology in such a way, we enable and empower a really large percentage of the population who otherwise would have problems and not be able to benefit. So we're giving better design experiences that really do benefit everybody and bring everybody into a level playing field, whereby we can be diverse and we can have different issues, but technology enables us really to come to the table at the same level. There are two more things that are really important: transparency and accountability. It's vitally important for companies to be transparent about their use of AI, and again, if we think about security and privacy and things like that. So it needs to show what is being used for AI in it, because a bank, for instance, may make an AI system to decide on whether a person is creditworthy, or a company may use an AI system to determine the most qualified candidate or candidates to hire. Therefore, stakeholders who are involved in projects that are using AI, should be required to comprehend how and why they function, so they can identify potential performance issues and things like safety and privacy concerns and unintended outcomes, and mitigate those, or at least be open about this so customers who are using them are informed and know about them when they're going in to use the system. It's also vitally important to be able to notify customers about where and when and how AI systems are deployed and used, rather than just rolling them out without absolutely no notice at all. Again, this is about keeping that confidence factor that customers have in companies at that high level, rather than accusing them of untoward practices. And not just transparency, but also accountability. It's not just a question of we create a system, we deploy it, and that's it. The people who actually create it need to be held accountable for it, both internally and externally, and we should be having industry standards for it. Microsoft has its own review board around the use of responsible AI, and every organization that is using AI capabilities should also be having this sort of thing within it. They should have an internal review body based on people from the business and people from other parts of the business as well, to provide oversight and guidance and legal requirements as well, to all levels of the company, to have that clear transparency view of how AI solutions are being used and in what way the company should be using it, so to enable it to be used in the right way. So with that, we're now going to look at a couple of the common vision solutions, and I've mentioned a couple of these already, but let's look at how we would actually get started with it. So, object detection. It's possible to create object detection machine learning modules by using advanced deep learning techniques, but these require significant expertise and large volumes of time, as well as training data. Now, using the customvision cognitive service in Azure, we are able to create object detection models that meet the needs of many computer vision scenarios with minimal deep learning expertise and fewer training images. So what we do is we would go ahead and we would create a custom vision solution. And we need to give it data. So we need to give it a minimum data set, and it tells us, depending on which custom vision item we're going through, as to what's the minimum number of images, because that can vary depending on the type of it. So we upload that data set, and we need to tag images to and the bounding boxes around it to provide the tags and the classes for it. And once we've done that in the initial data set, we then go ahead and we start training the model. We can add further images at a later point. We can always retrain the model. But we have to do that initial training of the model. And once that initial training is done, it's then possible to upload further images and then get the model to start suggesting tags automatically, in which we can tweak, which is then a saving of time. Once the model is then there, we can confirm our accuracy with it, and if it's accurate enough, we can then go ahead and we can then publish the model to be able to be used. And we can have iterations of the model, so we can see how many times the model has been trained. At the end of the training process, we have various metrics that are there. And these are precision, recall, and MAP, the mean average precision. Precision is what percentage of predictions did the model correctly identify. As an example, if we have 10 images of apples and the model found 7 of them, then the precision is 0.7, which is 70%. Recall, which is around the percentage of the class predictions made by the model which were correct. For example, if we have oranges, and the model predicted that 10 images are of oranges, but only 8 were actually correct, then the recall is 0.8, being 80%. And the mean average precision, the MAP, is an overall metric that takes into account both the precision and the recall across all classes. Now, just as a note, when we upload images to train the model, we should be giving as many sides to it, as many different vantage points that we can, in order for it to be as accurate as possible. So if you were taking pictures of, say, a cat, you wouldn't just take a picture from the front of the cat, but also want pictures from the side of the cat and sort of following the cat around, almost in a 360, so we could identify as best as possible. Now once the images have uploaded and it's busy training it, it goes through again, it's published, and we can use it. But what actually happens behind the scene? Well, as mentioned previously, essentially an image, as far as the computer sees it, is just a series of pixels, and the pixels can belong to different classes of objects, such as a background or a person, and working out what is referred to as semantic segregation. And this can be also used for other tasks, for instance in taking things like satellite or aerial imagery or imagery from drones and working out pictures from there. And this can be used for a wide number of tasks, for instance looking at sustainable farming practices, or for instance in the medical field for taking CT scans and MRI scans and predicting what it will be, the results in it. And we can see a couple of items on the screen that just show how it goes from the input image to the object class segregation to the object instance segregation, and how it goes across that. So how do we get started with this? Well, there are two main tasks. Again, we will upload existing images to train the model, and then we have to publish the model so we can do it. And these require a resource in Azure subscription. And there are two possible resources available. There's customvision, which is a dedicated resource. It can be either training or prediction, or we could actually use both. Our cognitive services itself, which is a general resource type that includes customvision along with many other cognitive services. So this is what we can use for training prediction, or both in there. Now the simplest approach really is just to use a general cognitive services resource for both items. And because of that, we only need to concern ourselves with one endpoint. That's the URL at which the service is hosted, and a single key, which is the encryption value used to authenticate themselves. If we choose to create a custom vision resource, we will have to choose, one or other. So we can choose training, prediction, or both for custom vision. But if we choose both, then two resources are created, and therefore you have two endpoints and two key encryption keys that you would need to use as well. One is for training and one is for prediction. And of course it's possible to take a mix and match approach, in which we can use a dedicated custom vision resource for training but deploy the model to a cognitive services resource for prediction. In order for this to work, it has to be in the same geo region within Azure, so both the training and the prediction resources have to be created within that same region. That you can use it if they're in different regions, it won't be possible to do. So here we're going to quickly run through just a couple of things again. When we train the model, we upload the images, we label them with the appropriate labels, then it trains, we can evaluate the results, we get the items out of it, and we go ahead and we publish it. But it's also possible to categorize images by the subject matter, and computer vision returns categories that are detected in the images. Now, as I mentioned earlier, these categories are in sort of a parent-child hereditary, and there are far fewer of them. They're, a little under 100 as opposed to thousands of tags. Now, categorization can be done by itself or along the newer tag model, and what these are returned as, these are returned again in the JSON code that can then be used for the categories for it. And this is part of the Analyze Image API, and it's able to call this through a native SDK or through REST calls, or include it in the visual features query parameter. Then when we get the full JSON response back, we simply can take that string and we can look at the category section to see what data is being returned to it. When we look at detecting common images, which is again similar to tagging, again the API returns that bounding box as we've seen for each object found, so we can use this to process relationships between different images in there, or again if there are multiple types of that same image, or there could be multiple types of multiple images in there. And there is no formal relationship between the tagging taxonomy and the object detection taxonomy at this point in time. We can see some more information on that around the screen. But not only is it able to identify things within the image, such as objects, we're also able to take data. So form recognizable data, optical character recognition, OCR. And this can take both printed and handwritten text from images and PDF documents. And what we can do is, for instance, we can upload things like business cards, or things like invoices, or license plates, or serial numbers, bills, financial reports. It's available as part of the managed service in the cloud, or it can be used on-premise. It also supports virtual networks and private endpoints to meet enterprise-grade compliance and privacy needs. Now, at the moment, OCR is available within English only. For handwritten text, it's also able to take digits and currency values away from images and PDF documents. And what it can do is it can take this, and then you can obviously take the results of that and use that in other systems. So if we would upload invoices or business cards, if you take the information, business cards is a good example, it could take the information returned and could then automatically populate it into a CRM system such as Dynamics 365. In terms of facial recognition and other stuff, it can take out not just the face, but it can also take, for instance, the gender, the age, emotions, that sentiment analysis around it. Is the person looking happy? Is the person looking sad? Does the person have glasses on it? The ability to process human face information is important in many different software scenarios. For example, things like security or natural user interfaces. If we're using facial recognition to log into an application through a webcam or through a mobile phone camera as well to check that it is that person, it can compare it to a stored image available for it. It's also possible to recognize if the person is, for instance, wearing glasses or not, which could otherwise skew the result and not allow them to log in. Now, the face detection feature is also available through the computer vision API. And you can use the face service, which is this service that we are discussing in the article, but there is more information available online. And how it works is it does an authentication check against two detected faces, or against one detected face to another, to essentially say whether the faces belong to the same person or not. So it can see if it's the same person in the image, which would be strange, admittedly, to have the same person appearing twice in the same image, but it could be possible if you thought of something that's computer generated. Or it can take a stored image and it can see if it validates against that. So again, if we're logging into an application, if we think of banking using biometrics, or logging into a phone using biometrics, it's possible to take the data from there, compare it with a stored image that we've set up, just as we would do things like fingerprint recognition, and it can compare fingerprints against it. It could also do the same thing for a face, taking a stored facial image and comparing somebody trying to log into the device to see if it's the same person. And there are a couple of other ways that it does. It could also be used to identify a face against a database of people. So for instance, automatic image tagging and photo management software, various social networks out there use a similar concept at the moment, whereby if people upload a picture, it can suggest already who appears in there based on their social network around it. Now obviously we need to bear in mind responsible AI and things like data privacy and security. So as with all the cognitive services resources, developers who use things such as the face service must be aware of the Microsoft policies on customer data, and there is more information on this online. And with that, we're now going to go take a look and do a demo around object detection. Okay, so let's take a look at a demo to show the capabilities of the object detection. And for this, I'm using the customvision.ai website, which allows us to just use the front end. It's obviously possible to call this through custom projects and APIs, and obviously if we build something in Visual Studio, as there are resources out there to do when we're putting it through into a specific application, it's absolutely possible to do that. But for ease of use, to be able to just show how it works conceptually, again, I am using customvision.ai. So the first thing we're going to do here is we're going to go and we're going to create a project, and I'm going to give it a project name. And what I'm actually thinking of doing is I'm going to call this cats. And I have a couple of different project types. It tells me what it is. I can classify, or I can use the classification, or I can use object detection, and it gives a couple of various items here. What I'm going to do for this first one is I'm going to do object detection, and I'm going to come back and do classification then afterwards. So I'm going to say object detection, and it gives me a couple of ones that are pre-trained, which is there. So general and logo and products on shelves. I'm just going to put general in there at the moment because I'm not going to use one of those. If I was a supermarket, for instance, I could look to use the products on shelves one. So once we've done that, we will have needed to create a resource here. So I've already got a resource creator that's there, and I can put a project description, which is AI model to recognize cats. And I've chosen cats because they're very friendly and fluffy creatures. Then I go ahead and create project, and it will then go and it will create the project. And here at the moment it tells me get started in the corner. So create project's done. The next step is upload images. Then I've got to tag my training images, and finally I've got to train my project. So I can now, I'm doing this through the front end. It can be called during code. You can look at an image library that you've already got somewhere, whether it's on the web, whether it's saved on a computer. But for my purposes, I've got a series of images which I'm going to use. So it tells me the file formats: JPG, PNG, BMP, up to 6 megabytes per image. Obviously this will be stored in Azure, so therefore just keep in mind the cost of storage that you may have. So if I click on add images, what it's going to do, it's going to take me and I'm going to add my images, and I've got a whole load of images which I've already selected. Click open, and it will iterate through that, and it'll tell me, here we go, I've got 20 images to be added. And just note over here as well, I actually have 2 duplicates. So don't worry if they're duplicates, because, well, we'll see when I click upload. So the next step is to click upload 20 files. And what it will do is it will go through the upload process, and it will pull those files in. And here we can see it knows that it's duplicate. It's already analyzed them as they were coming up, and it can see that one of them is a duplicate, so there are only 19 images really that it's uploaded. This is really helpful because if we have a library and we don't know if there are duplicates in there or not, instead of manually going through it, don't need to worry about that. It will take care of it by itself. So that's done, and I click done. And on the side here I can now see tags, and I can see tagged, and it will show me tags, or untagged. And at the moment there are no images that have been tagged. So let me switch to untagged, and I can see all of my images. And what we need to do is we're going to need to go through these, and we're going to need to tag them one by one. Now importantly, it needs a minimum data set of 15 items per tag, and a picture can have multiple items in it, but it needs a minimum of 15, and we'll see the capability of this. Or if, for instance, if we were going through and we were using the AI builder and Power Platform, which is where it surfaced as well, it will tell us that it needs 15 as well per item type. So I'm going to go through, and if I click to open it, we can see an image is there. Now you will see if I hover over, it's already suggesting some boundings around it, some boundaries around the image. So I can click there, and it will allow me to add a tag, which I click cat. And if I really want to, I can crop it to make it a bit better, but I'm going to be able to fine with that. So I'm going to put cat, and then that's tagged, and we can see it at the side. I'm not able to tag a single boundary with multiple tags on it. I would need to click again around it and draw, because I can just draw if I wanted to, and it's able to do there. I'm just going to cancel that one. So here I go, and I'm just going to go through my data set, and I'm going to need to tag, and you can see it's sort of automatically recognizing that, and because I've already got a tag there, it will allow me to click and use it. If I had multiple tags would appear. And again, it's really doing that. So we're going to work through the data set, and I would generally suggest have a reasonable amount in it, and sometimes I'm just going to crop the tag, crop the boundary a little better. So we're going to go through it. This was the one that there was a duplicate of. I'm just going to expand that because that should include the ears as far as I'm concerned. So just continue to work through. This one has a lovely expression on its face. So, and if I here as well, I could do pillow if I wanted to. Now, if I did this, I would need to have 15 images, a minimum of 15 items, with another item in there as well. So at the moment I'm not going to do it because it will tell me that it needs 15 for each one. So that's the reason why I'm not, but it's more than possible to do it. If you've got a much larger data set, obviously, and you know that you've got that, then it's possible to do it. It's also possible to do smaller items. So if, for instance, I wanted to just do an eye, I could tag just an eye in it, and it would recognize eyes. I'm not going to do that for the purposes of this demo, but it is possible to do. I would just be careful and recommend not against doing really, really small images or small parts of the image, and like that, for instance, to recognize an eye, because that can lead to problems with the AI model down the line. And we're going to do the entire cat actually in this one. And we've got a couple of smaller images, but note it's still sort of recognized that it's there. And we're going to, I'm going to leave that one as it is. So just continue to go through it. Here we've got one peeking out behind a chair. Expand that slightly to include the rest of the ear. Now obviously if it's a large data set, you can take your time to do it. You could have multiple people doing it as a classification. So that's fine. So we're just going to quickly click through this. They are quite adorable though. I can't click further more because that's got there. So if I click back, let me just see if I wanted to. So if I switch to tagged, we can now see I've got lots of them which are already tagged in there. I click untagged, we've still got a few. So just going to work through those. One's from the BBC. I didn't see, yeah, it's got that there, brilliant. Click next. Now, this actually has a lot in there, and I deliberately brought this in because it can show you just how busy an actual picture can get. And what I can do is, as well as I can just draw an item in here for it to recognize. So some pictures will get by default very busy with lots of items in, some won't. We should always try and take a picture that's not as busy as that, because that could cause problems and could lead to misprints down the line. So I've only tagged a few of them in here. Here we have two, so we can do each one. Notice how it's sort of recognized each one separately, and again we can see the boundaries on that. And there's one with a very startled face. And there we go. And now I can't click, back or so. It's already got it. So then we click X up here. And if we go into tagged, we can see they're all coming up as tagged, which is fine. Untagged, there's no untagged one. So at that point then, what we can do is we would go ahead on the performance. There's nothing coming up performance yet because we haven't clicked train. So we're going to go and click train. And it'll ask us what are the types of training. The hover over will tell us, advanced training. It can be really great to do, but obviously will take more processing time and other things like that. We're going to go for quick training. And we click train. Now, I've given it a data set of a few images. There are, I think, there were 19 or so, as it said to us, one of which are duplicate because we selected 20. And what I've got is I've also got a test image. So this is now going to go away and use Azure Cognitive Services in the background. And depending on how large your data set is, will depend on how long it takes to do it. If we had done advanced training, we could throw more resource at it, but this is just allowing us to do it. And we've got some probability thresholds here as well, which I could change if I wanted to, but I'm not going to bother on that. So what we're going to do in a few minutes, we'll see what happens once it's been trained. And we now get the initial stats, so it will tell us the precision of the model, it will tell us the recall of it, and of course the MAP, the mean average precision. And what it can do, it can tell us, the performance per tag and how it's done. So that's great. If we click Get Started, it's now all trained. So once a model is trained, obviously it could then be used. It can upload images into it, obviously through any custom applications that we use it, and then it would return. What we can take a look at, if we go to predictions, it will then ask us around the endpoint around it or quick test, and it will go ahead and allow us. We can, of course, go back to training images, and we can pick up additional ones. So what we can do is if we go to untagged and we add an image, there's actually something really nice about this one. Because if I go to, I'm uploading just one image, it will upload an image, and it's there. What we now have also on the side is it's got get suggested objects. It won't do this if we haven't initially trained the model. We have to go through those initial 15, and we click Get Select Suggested Images, Get Select Suggested Objects. And obviously being a demo, that hasn't worked, but that's fine. It is there, it does work. What we're going to do is we're going to now go and take a look and actually see what happens once we return. So if we go to Quick Test, what we can do is we can browse a local file, and here is one that I've got up and running. So if I'm going to import it, it's now going to bring this in as a test, and it's now going to say it's got a predicted object threshold. So that's there, and we can see that it's 61.5% sure that this is indeed a cat. So that's really good. Obviously it's possible to train up the model better and get a better image of it. It's got iteration 1 there, but this shows a model that can be used then for it to be able to see. If we take off the regions, it's gone there we go, and it says that it believes this is a cat, not the rest of it. So I think that's pretty good, given that I've only given it a very small image sample, and given that cats are indeed very different in terms of the size of them, the colours that they have, and the angles that it was taken. We should be giving it a training set of as many angles as possible for the item that we're looking for, so that the computer can, of course, the model can be as accurate as possible when going ahead and training it. So once you've built and trained your model, you can then enable your application. If it's a custom application or a website, a web service, it can then go ahead, it can point to your Azure model that you've trained. You can allow users to select the images that they want to, whether it's from their local device, or if they want to upload it, say from a website, and point it to it. As we can see here, through customvision.ai, we have the ability to enter an image URL, which it will then go and analyze, and you can then get the results that come back to it, and obviously return the tags to it. In a custom application, you would be returning the tags and in a JSON format, and be able to see that an image contained or an image didn't contain, along with the accuracy rate of what it was, and then you could obviously use your own application to surface how you wanted to use it going forward. Now also to remember, the object classification item shows where in the image the item is. So it will return a set of coordinates for the boundary box where the image is contained, and obviously if there are multiple images of that type within the picture, it will return multiple results for it. And here it gives a couple of predictions available. Now if I switch across into a different project that I've got done, which I've done with logos, we can see again I've got precision, but my recall and my MAP values are now quite different. So what I'm going to do is I've already got a series of training images which I've given it, and I'm using the logo one, so I'm going to go ahead and I'm going to do a test on it. So again, I'm just going to upload a file for it. I want to take a specific one over here. So there we go, so I've given it the Floop logo. And interesting enough, so it's come in here and it's showing it with a prediction rate of 83.6% for the actual words that say Floop, but it hasn't included the logo bit to the left. So obviously this will depend because there are a large number of different logos available on the market, and the accuracy of this will vary over time as to what you're giving it as the training data set, and obviously which images you're passing through to it. Now it's also possible to have a model that isn't about object detection, as in where in the image it is, but a classification, as we've mentioned earlier on. And what this will do is it allows us to give it an image, and it will then go ahead and say whether that is indeed an item or not. A good example that I know of, seen demoed before, is the hot dog or not hot dog. Does something look like a hot dog? In this case, I've got a model trained up on burgers. So if I just switch across to it, I've given it a number of burger pictures. And when we come to classification, it's possible to do multiple tags on it. So we can say an image could detect multiple things. Again, it's not showing it within the image as to where it actually is. So if I look at this one, which some quite delicious burgers, what I'm going to do is I'm going to do a quick test, and I'm going to give it an item for it. So again, I've got a test image stored locally called burger test, and this will then go ahead, and we can see it doesn't show it on here as to the boundaries for it, but it turns around and says that it's 95.6% sure probability that it does contain a burger. In fact, there are actually two burgers in the picture. Potentially that could be throwing it off somewhat. Furthermore, using either the classification or the object detection for computer vision, it is of course absolutely possible, as mentioned before, to use things like the celebrity and landmark recognition models, which are pre-trained and available from Microsoft. So using object detection, for instance, we could upload a picture containing several celebrities in it, and it could then go ahead and detect where the celebrities are in the picture, or using classification to whether that person obviously was a celebrity or not. And things like landmarks could go in the same way for it. So with the demo that we just completed for object detection, let's go ahead and take a look at the Azure tools and services that are available for computer vision tasks. And what we're going to do is we're going to start off by looking at the actual capabilities of the custom vision service, or rather the computer vision service. We'll look at the custom vision in a moment. So out of the box, Azure's computer vision service provides access to advanced algorithms that can process images and return information. And the aim of this is it's a service that's capable for developers to plug straight into using an SDK or using the REST API directly, so we can create applications in which we can upload images to be analyzed by computer vision, the results come back, or we could create websites which we could point to URLs for it. And computer vision really is very, very good in what it can do. It can power many digital asset management scenarios. Digital asset management, of course, is the business process of organizing, storing and retrieving rich media assets, metadata, managing digital rights and permissions. For example, a company might want to group and identify images based on things like visible logos, faces, object colors, and so on and so forth. Or you may wish to automatically generate captions for images and attach keywords so that they're searchable. So what computer vision does is it goes ahead and it analyzes images for insights as to things like their visual features and the characteristics. It can also identify and tag visual features in an image from sets of thousands of recognizable objects, living things, scenarios, scenery, and action. If the tags are ambiguous or it's not common knowledge, the API response provides hints to clarify the context of the tag. It can detect objects, it can detect brands such as commercial brands, it can categorize images, it can also describe an image, it can detect faces, it can detect image types, for instance, is it a line drawing, is it a clip art, it can detect color schemes, it can also generate a thumbnail, if that's what we're actually wanting to do with it. Now, it's not only possible to just use the capabilities of computer vision, but as I mentioned a moment ago, it's possible to have custom vision, which allows us to build, deploy, and improve our own image classifiers. We can create a custom model based on what we're trying to do. And what this does is it uses machine learning algorithms to apply labels to images. So whoever's developing the application or the resource needed needs to submit groups of images that feature and lack the characteristics in question. We go through those, we label those, we train the model through machine learning to understand what it's actually looking for in the images. And then what it can be done is we can then feed images through to it to test and finally publish it to be able to use the model. And custom functionality is really divided into two types of features. Image classification, which returns one or more labels to an image. So for instance, an image of a dog, it can return dog, or if there are multiple dogs and cats in there as well, it could say that there are dogs and cats in the image. Or object detection. And what object detection does is it brings back the coordinates in the image, what we call a bounding box, so the height, the width, the x, the y coordinates of it, where it can be found, so we can identify not only what is within the image, but where within the image it is, which is very, very helpful. And custom service is really optimized to quickly recognize the major differences. So you don't need to have a massive data set to start training your model on. You can start with a small amount of data and continue it over time. It's available through SDKs as well as a web-based interface on the customvision homepage, and it allows both developers to be able to do it as well as people who will not code. They can do it through the front end, through the website for it. We also have the form recognizer service, and what this does is it can look at forms to identify data on it and pull data back. It's another cognitive service, and it uses machine learning around it. And what we can do is we can go ahead and build and train models for it. So if we think of, for instance, invoices will have a standard layout, so we can train the model to look where it looks for the date, the reference, the amounts, and all the rest of that, and then return all that data back that can then be used further on, or in different scenarios, it could go and populate a database somewhere, for instance. Now, Form Recognizer is comprised of custom models and things like there are some pre-built ones such as the receipt model, and there's Layout API, and it's called by using the REST API for it, and then we can integrate that into workflows or applications as well. The capabilities of it: we have custom models, we have the pre-built receipt model as mentioned, and the Layout API. What this allows us to do again is to extract all of the information that we need, train the model, custom train it as necessary, or we could use some pre-built models such as the pre-built receipt model, which can extract data from USA sales receipts in other locations. Might not be as accurate, so then you would go ahead and you would build a custom model for it. And it's also possible to extract text and table structure from documents using the Layout API. So with that, we're going to go ahead and perform a demo showing Form Recognizer in action. Let's now take a look at the Azure Form Recognizer functions. So at the moment I'm in my home portal for Azure, and I have a variety of things that I've already set up. I've set up the Form Recognizer for cognitive services, I've set up Azure blob storage and a variety of other stuff. And what I'm going to do is I'm going to go to the Form Analyzer website, and there are several different models that are available here, items that I can do. I can use a pre-built model to get data, I can use a layout model to get text and tables, and I can train and use a model with labels. And this one would then allow me to provide my own training material and do the learning through it. So if I had a custom invoice layout, what I could do is I could upload things like custom invoices or a variety of other forms and start training the model for it. But what I'm going to do first is I'm just going to show how we can use a pre-built model provided by Microsoft to automatically show data. So here we go. I'm going to click pre-built model, and it will ask me to connect to the Forms Recognizer service endpoint. So what I'm going to do is I'm just going to put in the details for it, for the endpoint that I've created for that, and my API key, which thankfully stays hidden. and it will ask me a locale that I can select, which I'm just going to actually leave as ENUS, and the type, which in this case is not going to be a receipt. That's available. I'm going to select the invoice. I also have the option for business card. These are the 3 pre-built models that are available. So I click invoice, and then I can select, do I want to take it from a URL file if I've got it on a web server myself, or I could point this, for instance, to a SharePoint location with a list of documents or a variety of other things. Obviously I'm using this front end to demonstrate the capabilities of it, but the aim would be is that we would have form recognizers set up. We've got the endpoint, we've got storage, we could serve as a custom application in which we could upload documents through it. So for instance, we could allow the ability to capture receipts off a mobile device for somebody in a company, and all they would need to do from the company issued device, or even from a personal device, assuming it would be connected in with the application, is they could go to a company website, or they could have an app running on the device itself. They could snap a picture of it and it would then upload it. So let's take a look and do a couple of examples of this. So at the moment I've selected invoice, and I'm going to use a local file for this because this is something that I've got already. And I've got here a file which is in PNG format. It could take it as PDF format, it could take it as JPG format. So I'm going to click open, and at that point it will then fetch and it will then come up in the screen, and if I zoom in I can now see that this is a sample invoice that is there. So once I've got that in there, I'm going to click Run Analysis. And it's going to go ahead and it's going to analyze this document to see what data it can pull off there. Again, this is using the pre-built model. So I can now see that I've got hovering over, I've got, squares, outline boundaries around various parts on it. And I can zoom in actually with the mouse wheel, which is very useful. So if I can scroll down here at the side, it will then tell me at the side, it will show the various fields. So it's captured the amount due field, and we can see that it's highlighted in different colors here, so we can see what it corresponds to. And it's got the billing address, and it gives us the confidence levels that it's there, and this is pretty high, the confidence level, getting 100% for the subtotal here. So it's taken the text of it and it's then identified the field of it. So this is pretty good in terms of it. And what I'm now going to do, we're going to rerun this and we're going to give it a business card. So again, I'm going to give it a business card, and I'm going to just browse to this. So I have the business card here, and I'm going to, well, let me give it an easy business card to start with. So it's a general business card and it's got analysis going on. And in the predictions results we can see here again we've got a confidence level on it. Incidentally, I'm not quite sure why the first name and last name are coming up as NAN, but we've got pretty high confidence. Now this is obviously clear white, it's got a white text background. Let me change the business card to something a little more complicated. We can see that it's now there again. It's got a variety of other things in the picture as well. So again, if I run analysis on it, this will now show us that again it's picked it up pretty well. Again, it's easy because the business card itself has a white background. So that shows it. And finally, I'm going to show a pre-built model with a receipt. So I'm now going to go and I'm going to change the type. Obviously important to do that. And these are of course parameters that can pass through, and you're telling it where you would get it from and what type it would be. So I've got a receipt. There we go. And this is actually in a different language. This is not English. So let's run an analysis and let's see what it picks up. Again, it's picked up pretty much a lot of items. It's picked up, the name of something. It's picked up the amount. In this case, it's not actually picked up the total of it, the VAT items. It's not picked up the total price, but this gives an example, and obviously you would, use it in the appropriate way. If we go back home, what we can also do is we can take a look at using layout to get something. So again, what we're now going to do is we're going to get a file. So I have a variety of files available, and at this point what I can do is I can see the layout of it. Again, now running some analysis, and what it can do, it will show the layout of this. Now layouts are really important because when it comes to forms, ideally the form should be in the same layout, because if the form is different layout, if you have different numbers in different places, you could have the data at the top, at the right, at the left, halfway up, halfway down, quarter of the way down, 2/3 of the way down. It's looking for that layout. You would train it on a specific layout, as that way it knows where on the page it's looking for the data. So if we download the layout results, what it's going to do is it's going to download a JSON. And what the JSON does, if we just open it up, I'm just going to bring in my Visual Studio, expand it, just close down the items that I have on the side here, just to make it show a little easier. So the JSON then returns sort of the boundings on that, so it's got confidence factors as to where it thinks. This is essentially where it believes everything is. And it will analyze it, and it will turn around and say, right, for instance, it's come in with these things. It thinks this fabricum.com, where does it appear, what is the confidence on it, what are the words, and obviously it gives the coordinates on the page, which is this bounding box, and it will go through every single item on the page and do it. And this, of course, is very important, as we can see when it comes back with items, as this is what's really underlying the whole AI model, that it knows where to do it and how to then recognize it. So if we minimize that, that's how we do that. And it gives also layers, so is it a text layer, is it a table layer, labels, and it's got the ability to show all of these different items on here as well. If you wanted to go and train a custom one, then we provide our own training data, and then it does it. So this can be a specific form that we're using. And what that allows us to do is to go ahead and, we would go into there, we would go and create a new project and give it project settings. This is how we can train it through the front end. Obviously it's possible to do this programmatically as well, through a custom application, through the command prompt, for instance, and to load things in. So we would go ahead and give all the details in order to connect into our Azure estate. And with that, what we can do is we can train some very custom forms. They may not be standard style invoice layouts. They could be, for instance, a technical quote, or they could be a financial document in which we're trying to extract information. If we think of something like the insurance industry, they'd probably want to gain, specific information coming back. It's not a quote template, it's not an invoice, but it would have details of, say, insurance claims and the claim date and the claim reference and everything around that sort of thing. So this is where each industry, each vertical, each company even can go and train their own absolute model to be able to handle it in the way that they want. And with that, we conclude the demo. So as we've now just seen, we've had that demo of Form Recognizer, and that really brings us to the end of this first module. We've gone through an identification of features of common AI workloads. We've gone through the identification of the guiding principles for responsible AI. We've identified common types of computer vision solutions. We've identified the tools and services for computer vision tasks. And we've done a couple of demos to show, vision processing solutions in terms of things like objects, in terms of things like classifications, and of course the Form Recognizer. The next module, the Day 2 module, is the Introduction to Natural Language Processing, NLP, and Conversational AI. And in that we're going to go through features of common NLP workload scenarios, again identification of the Azure tools and services for NLP workloads, identification of common use cases for conversational AI, and identifying the Azure services specifically that are surfaced around conversational AI. But before that, before we get to it, there obviously is self-paced learning resource available on aka.ms/learn, and there are various modules that are available, such as getting started with artificial intelligence, exploring computer vision, exploring conversational AI, no-code predictive models, and a variety of other things. And some of these contain labs in which you can go ahead and you'll be able to spin up your own trials and demo the solutions out for yourself rather than just working through theoretical scenarios. And I would highly recommend that you go away and take some time to go take a look at it. The content on Microsoft Learn is absolutely amazing, keeps getting expanded over time, and really is a great starting place for learning about it. And not only do we have these modules available to us, but once you get into it, it will then suggest other modules that you could be interested in at a tangent, which could also expand your knowledge of the various solutions and guide you as to how you may want to go ahead and implement the technology for the benefits that you have identified with yourselves and with your customers. So with that, we would like to thank you for staying with us through Module 1 and are looking forward to joining you again with Module 2. Thank you so much.
Thank you for sharing your knowledge with us today. I hope our participants will really benefit from it. Also, as an additional resource, let me remind you that this series on AI 900 Microsoft Azure AI Fundamentals will also be available for you to watch on demand at aka.ms/mpn/VTS. Thank you to all the participants for joining us. Hope you enjoyed today's session. We'll see you again tomorrow. Goodbye.